So if you want to find the PD across your AB here, which is a thermistor, so we use a standard formula for the potential divider. That means this voltage, so will be this resistance over the total resistance times the total voltage, and you get 2.7. So if you want to explain why for constant current, the PD is proportional to the distance, so you need to first talk about this wire. If R equals to rho L over A, since this is a uniform wire, then R will be proportional to length. Because uniform wire means the resistivity and the area is constant. So resistance is proportional to length. But also, since you have the formula V equals IR and the same current passes through here, alright, so you can say that V is proportional to R. So since your V is proportional to R, your R is proportional to length, so your V will be proportional to the length. So the next part is that the contact M is moved along PQ until the voltmeter shows 0 reading. So you must remember, if the voltmeter shows 0 reading, it means that there is no voltage or no PD across these 2 points. So if there's no PD across these 2 points, it means that the this potential at B equals the potential at M. Do you understand that? Now what about these other points? So we say that these two have the same potential, right? Because the voltmeter is 0. Now since your cell here, which is so cell here is 4.5 volts, so you can assume, right, that this side positive, so this is 4.5, this is 0. So 4.5 volts, 4.5 volts, 4.5 volts, 0 volts, 0 volts, 0 volts. Why? Because there are no resistances in between. So this is 0 volts, 0 volts, 0 volts. So can you see that since this potential is the same as this, and this 0 and 0 same, so can we then say that the PD across the across the thermistor here must be equals to the PD across the MQ. So that is the conclusion. Alright, so what is the PD between contact M and contact Q, which is here? It must be equals to this PD. Alright, and this PD we have actually calculated from the earlier part, remember? The PD across the thermistor, so you can assume it's the same answer, 2.7 volts. And then the next one, what is the length of the wire? So this one we can use our ratio for formula, because 4.5 volts is across the entire wire, which is 1 meter. So what is the length? That will give you 2.7 volts, alright? So use ratio. 1 meter is 4.5. How many meters will give you 2.7 volts? So V2 or V1 equals to L2 or L1. So V2 is our final voltage, L2 is our length that we want to find, QM. 4.5 is the whole thing, and 1 meter is the whole thing. So in the end you will get your LS 0.6 meters, which is 60 centimeters, because they want in centimeters. So the last part of the question says the thermistor is warmed slightly. What will happen to the length of the wire if you want the voltmeter remain at 0 deflection? Now for a thermistor, when we increase the temperature, what happens to its resistance? Decreases. Okay, very good. So the resistance here decreases, so the voltage it carries will be more or less? Less. So if this voltage is less, this voltage also must be less, because this PD must equal to this PD. So how to get a smaller PD? By moving the M towards Q or moving towards P? Towards Q. Well done, Man Hong. So for this question, if you want to find the EMF of cell Y, you will notice that it is a potentiometer. So the voltage across this will be given by this length, and the voltage across Y will be given by this length. So we can use the formula for potential divider, which is V2 over V1 equals to L2 over L1. So if you want to find the EMF of cell Y, let's call it Vy. Let's call it Vy. Okay, Vy. So equals to the length, which is 0.9. over the other length of X, so 0.7 times the cell of EMF of cell X, which is 1.1, and you'll get 1.4 volts. But there's a shorter way. You'll notice that since V is proportional to length, so you will notice that this length is longer than 0.7. So if 0.7 is already 1.1, so 0.9 should be bigger voltage. So therefore the only answer is D, 1.4 volts. Okay? Like in this case, right, what is the answer? What's the correct circuit? So the correct circuit, remember, you won't use the potentiometer. Positive must be connected to positive. and the galvanometer must be at the bottom circuit. So answer is B lah. If you want to find the potential difference per unit length, that means you must know the voltage and you must divide by the length. So since this is already a ruler, so we can find the length from the ruler itself, right or not? So then all we have to do is to find this PD. So what is this PD equals to, E1 or E2? So if I know E2, then it will be the PD across XT, right or not? So if I know the PD across XT and divide by the length, wouldn't I get PD per unit length? So the answer is, you must know E2, boy. So to find the percentage reduction in power, you must first select an appropriate formula for power in the heater lah. Remember, we have three formulas, which are P equals to VI, P equals to I squared R, and P equals to V squared over R. So the question is, which formula do we want to use in this case? Now, since they gave you the voltage, so the two likely candidates will be either P equals to VI or P equals to V squared over R. But which is better to use? Now, if you use P equals to VI, is I constant? If you use P equals to V squared over R, is R constant? That is the main question you must ask yourself. Now, in a circuit, if you can't see, I just draw for you. If you put a resistor in series to the supply, if this is 230 volts and you change it to 220 volts, now will the current in the same resistance change or not? Since your I equals to V divided by R. So R is constant, so when you change the voltage, what happens to the current? So it changes. So therefore current is not constant, so we cannot use this. And since voltage is not in this formula, we also cancel this. So we are left with P equals to V squared over R. Because no matter what happens, they did mention to you that the resistance is constant. Constant resistance. So therefore, how we will solve is using P equals to V squared over R. So the percentage reduction in the power means you must take the power that is reduced over the original power. So what is the reduction in power? You take the bigger power, which is how much? 230 squared. Okay, so 230 squared over R minus the smaller power 220 squared over R. Now you don't have to take initial minus final or final minus initial because you just want the change. So divide by the original power. So that one you have to use 230 squared over R. So you'll notice that all the R will cancel out and you will end up with 230 squared minus 220 squared over 230 squared. Now this is not yet percentage, so you have to times 100. Alright, so the percentage reduction, alright, the whole thing you must multiply by 100. So therefore you will get your answer, which is 8.5%. Alright, so you must write it in maximum 2 SF for percentage reduction or percentage change.